And we are live. Hello and welcome to our virtual Lunch and Learn. Today we're talking about safety over Ethernet. My name is Rachel Green. I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today are Donnie Bartlett, PLC Specialist, and Gary Smith, Systems Engineer, out of our Greenville, South Carolina location. Out in the comments section, ready to answer your questions today is Kevin McDonald, Industrial Controls Product Manager. He is also out of our Greenville location. We'll also have a Q&A portion at the end of the presentation for Donnie and Gary to answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us. As you come in, please let us know where you're tuning in from in the comments. I already see we have Kevin and Benjamin. Vishal and Joel, welcome. As we continue to socially distance, we're happy to be able to host these live sessions here on YouTube, making it possible for you to join us from the comfort and safety of your own homes and offices. Welcome, John and Leanne. Thanks for joining us. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. We'll also be continuing this series every Wednesday at noon, so be sure to join us on your lunch break. For anyone just joining, welcome to our virtual Lunch and Learn, Safety over Ethernet. Let us know where you're joining us from in the comments section. We'll be looking for questions as you have them in the comments, and our presenter, Donnie and Gary, will detail the latest products and techniques in Ethernet safety along with their advantages. Our specialist, Kevin McDonald, will do his best to respond to your comments and questions as we go along. We'll also have a Q&A segment at the end of the presentation to address some of those questions in more depth and to allow some time for follow-up questions if you have them. Welcome, Tom and Tim from Michigan. If you'd like to reach out afterward, or if you have further questions for Donnie and Gary after today's presentation, you can send us an email at the email address you see there on the screen, mcmclive@mc-nc.com. Be sure to let us know which session you attended and we'll direct your questions to them. We'll have that email address on the screen for you at the end as well. Welcome, Austin and Bob. All right, it looks like we have a number of attendees now. So Donnie, I will pass it over to you.
All right, hello everyone. Thanks for joining in today. As Rachel said, my name is Donnie Bartlett. I'm sitting here with Gary Smith, and we're out of the Greenville, South Carolina, McNaughton-McKay office. As you well know, today we're going to talk about safety over Ethernet IP. So we'll get into it. If I can get my slide to advance, there we go. All right, just a little bit of our agenda today. It's not going to be a long presentation. We're going to talk a little bit about a SIP safety introduction, what SIP safety is, the latest devices that Rockwell Automation and McNaughton-McKay offer that'll fit over a SIP safety network, talk a little bit about drive safety instructions, and at the end we're going to have some SIP safety integration examples using a lot of the devices that we talk about during this. To begin, it has to be said, anytime you're dealing with a safety project, the absolute first step in that process is to do a risk assessment. I'm not going to go deep into risk assessments here, but I did want to just mention that has to be done. The result of a risk assessment may produce a category that you're designing to. It may present a SIL level or a performance level, depending on which standard, what your process is and which standard you're following. This slide kind of represents the performance level, and we mainly pick that because a lot of what we do today will reference the performance level, the 13849. So just a reminder that risk assessment is absolutely crucial. In going through a safety project, Rockwell has an excellent resource called the SafeBook 5. It's available from Rockwell's website on the literature library download site. And it goes to everything from risk assessments, standards, system design, and so forth. It's an excellent resource. So if you don't already know about that and looked at it, I encourage you to do that. All right, SIP safety. Number one, what is SIP safety? The main point I want to make here is SIP safety, or SIP, is not a Rockwell automation standard. A lot of people think it is. It's actually an ODVA standard. It's based on the ODVA standard of Common Industrial Protocol, or SIP. And it really just adds functional safeties, for Ethernet IP and DeviceNet networks. The standard covers, how devices communicate to each other, from I/O to light curtain, safety peels, and so forth. An important point is it allows for the mixture of safe and regular devices on the same network, which I think is a real advantage in SIP safety. And another important point, safety is handled in the devices, in the end devices. So that really allows network media independence. Now, Rockwell products are primarily on Ethernet IP and DeviceNet. Certainly, these days we prefer the Ethernet IP, but the media is not important. It doesn't have to be copper, it can be fiber, it could even be wireless. Again, stressing that the safety is handled in the end devices, not in the network. All right, let's talk a little bit about how SIP safety works. We've got a diagram here. We're not showing the Safety PLC, but this is where the safety message is going to originate. And it's got a K5500 servo drive out there with SIP safety in the servo drive. Now, if we look at the SIP packet shown here by the safety message, there's several things that we can notice. Number one, anytime we deal with safety, we want the three qualities of duality, diversity, and diagnostics. So we're going to see how those apply to the message. Number one, if we look at duality, you can see in the SIP message, I have data A and data B. It's the same data. So we are sending the data twice. That's our duality. The diversity is we take one subset of data and invert that. That gives us some diversity. In terms of the diagnostics, we have the timestamp and CRC for each of the data sections to give that diagnostics. Now, as we send this message, see the animation here. We'll send the packet to the drive. The drive also has to have duality, diversity, and diagnostics. So you can see here, there'll be two safety processors in the drive, gives us duality, and one will get the normal data and one will get the inverted data. So that gives us the diversity. Of course, the drive as well has diagnostics as far as timestamp and CRC as well. So in the drive, each processor looks at its data, the normal data or inverted data, makes a decision whether safe torque off, if that's what we're dealing with, is enabled or not. If the two processors in the drive agree, then it executes the command. In this case, it will be executing a safe torque off and stopping the motor. If there's any discrepancy in the two processors or processes in the drive, of course, it would go to the fail-safe condition, as well as if there's any interruption in the network. Again, the safety is in the end devices, so the safety processor in the drive would establish a connection. If that connection is interrupted or takes too long to communicate to each other, the system is going to go to a fail-safe or off condition in this case. All right, what are the advantages of SIP safety? To me, the biggest advantage of SIP safety is that we can a lot of times achieve higher levels of safety that are just not available in hardwired solutions or difficult to implement, or even not only hardwired solutions, but other maybe network solutions. A lot of times we can get up to a SIL3 PLE level. And again, sometimes we can't do that with other systems. A lot of drives, we can only get to a PLD or category 3 level through safe torque off boards and so forth. This is something that allows us to extend that. Of course, it's obvious we get a reduction in wiring. We also can those of you that have to validate your code, you know, we can develop code that we have validated and reuse that code, so we don't have to go through that validation process a lot. Certainly, this puts everything into Studio 5000. We can, you know, we're doing motion control within that. We're doing regular machine animation with that. Now we can do safety within that. So we don't have to have separate programming softwares and separate processors to do everything. We got some modularity in terms of design and safety zoning. And it's a lot easier to do troubleshooting. We don't have to run extra contacts back to I/O modules to see which devices are triggered or so forth. So there are a lot of advantages here. Okay, in terms of the products that we offer and the systems that we have, this presentation, we're basically going to do that in 3 parts here. With any safety system or with any automation system, obviously you have a logic solver that takes inputs and then writes to outputs. So that's the order in which we're going to present information that we have today. So we'll begin with input devices. Now, one thing I want to mention is this is not an exhaustive list of all Rockwell safety input and output devices. We have chosen to specialize in Ethernet IP devices where you can get information into and out of your safety tasks directly. So certainly this is not the only safety devices that we have. The first input device that we want to present to you is the multifunctional access box. We refer to it as MABE for short. It's basically a gate switch. It's, you know, for allow full body access to a system. You can see on there, it's a gate switch, it's a handle, it's a locking mechanism. We do have integrated e-stop, as you can see. The controls in terms of push buttons and pilot lights and so forth are configurable. We have many different options for you. We have the option of connecting an enabling switch directly into that. It is powered by 24 volts, and of course we have dual port Ethernet. The thing we like to say about this device is basically you take 24 volts and an Ethernet cable to it and you're ready to go. You got a complete safety system. All right, some more bullets about the MABE. You know, high holding force, misalignment tolerances. It just does have the escape release. It is rated for up to PLE category 4. So very, very high rating, as high as you can get in terms of safety on this. As I mentioned, we have our choice of controls. We can configure the different status lights and push buttons on it. We do have left or right hand operating, you know, sliding your hinge doors. And another big thing is Rockwell has sample code available for this MABE. You can go to the Rockwell website, sample code site, download the code and put it directly into your Logix processor. It's pretty quick and effective. Relative and new device that we have in terms of the safety inputs are our SIP safety encoder. This is, I think, only been out a few months now. It does allow you, as you see there, it does allow you to take advantage of drive safety functions within Studio 5000. It is SIL3 PLE capable. Of course, it is Ethernet ready, just like the MABE. You take 24 volts and an Ethernet cable to it and it's ready. And the encoder data is available directly into the safety task. You can see on the right some of the things that information we can get into the safety task are position and velocity data. We got dual channel feedback and discrepancy checking. So as you'll see later, we have safety functions embedded in some of our drive products and the feedback within those drives. This is a way to add that safety feedback on something that does not offer that feature. And I just wanted to mention here, this is something that Gary will talk about a little later. The SIP safety encoder allows you to get information back into the PLC for the following safe speed and safe stop instructions in the PLC. Of course, all the safe limited speed and safe stop instructions are something that are in our L8 controllers, our GuardLogix 5580 and Compact GuardLogix 5380. All right, next input device is our 450L light curtains. I do want to mention that this product hasn't quite been released. We do expect it at least by the end of this year. It is a product that's very close at this point. And really, as far as I know, really the only safety light curtain that will go on Ethernet IP. It is capable of SIL3 PLE. The cool thing about this light curtain is we have two identical sticks, and the plug-in modules define the identity and features of the module. So as you can see from the graphic there, we'd simply choose an Ethernet IP plug-in. And you see some, I won't read it to you, but you see some of the features, size ranges, and so forth of the light curtain there. Laser alignment, hand and finger resolution, and so forth. And again, this is going to connect directly into our safety task and provide the information. A little bit closer look at the light curtain. We have a plug-in module, Ethernet IP plug-in module that's going to go into the light curtain. And then we have a block that will, I can plug at least as many as 2 light curtains into. So it's a completely modular system. Our last input device is the SafeZone 3 SIP safety laser scanner. This is kind of a look into the future because this device does not have a release date yet, but it is something that's coming, and we wanted to make you aware of it. At this point, this will be up to a PLD capable. We'll integrate directly into the safety task. We have the AOP and Premier integration into Logix. So like any other Ethernet IP device, when you add it to the IO configuration tree, all your tags and everything are immediately created for you. So that's all of our newer SIP safety Ethernet IP devices. We'll go into the logic solvers, the controllers right now. Probably most of you, if you're watching this, you're already familiar with most of our PLCs. So I don't know that this will be anything new. So if we begin with our compact GuardLogix processors, our 5370 and our 5380, also known as the L7 and L8 controllers. The GuardLogix 5370 has been out for a little while. Of course, it supports motion and safety as well, up to 16 axes. It is a SIL3 PLE controller only. And when you purchase the safety controller, you also have to purchase the motion as well. And of course, it has 100 meg Ethernet embedded. The 5380. Most of you are probably familiar with the differences in regular 5370s and 5380s. You certainly can do motion on this, a higher axis count with the 5380. We do have a gig port in terms of Ethernet, so that's exciting. Cool thing about the 5380 is with the dual port Ethernet, they can be the same IP address, or you can split the IP addresses apart, have 2 different subnets. Until recently, we've had the SIL2 PLD version only of the compact GuardLogix 5380. Just recently, in the last several weeks, Rockwell has released the SIL3 PLE version of that. The cool thing about this is if you only need a PLD, we can accomplish that with just the safety processor. When we go up to a PLE version, it includes the safety partner. Safety partner comes embedded in with the controller in the same housing. But we do have that available now. And of course, as I mentioned earlier, you need the L8 processors to deal with the safe limited speeds and safe positions and so forth with our servos and VFDs. All right, going on to the GuardLogix controller, kind of the same story. We had 5570s and 5580s. All of you know that with the 5570, we can go to a safety processor, but we always have to include the safety partner, and that's rated to a SIL 3 PLE version. Like the compact GuardLogix, when we go to the GuardLogix 5580, if we only need a PLD, we can just have the safety processor by itself, or we can change that to a PLE application by adding the safety partner. And in terms of Studio 5000, the codes you have, it's really just a checkbox to go back and forth between one. So if you had a PLD, you wanted to make it a PLE, you can go into a checkbox in your program, add the safety partner, and now you have a PLE application. And of course, the other things that come with the L8 processors, the safe limited speed and safety instructions, as well as the gigabit Ethernet. All right, a little bit of SIP safety IO. This is debatable whether this is a Ethernet IP product. All the distributed IO can go on Ethernet IP, so I just put something quickly in here. Just wanted to make sure that you are aware of some of our newer safety IO products. We have the Point Safety IO, which has been our bread and butter for a number of years now, still is. We have the Armor Block Safety IO, which we've had for a while. But in the last year, Rockwell has added some other IO platforms. Number one, we have 1756 IO that can be in the local chassis of a processor now. It also can be in a remote chassis if you have a 1756 remote chassis. We have compact safety IO now. Similarly, it can be local IO for a 5380 controller, or if I put an Ethernet adapter here, this can be distributed IO. I jump down to the Flex 5000 IO, same thing there. We have several safety modules in that now. Of course, Flex 5000 is always a distributed IO. One thing to mention about the Flex 5000 as well as the Compact 5000 is they are a gigabit Ethernet platform. So if I put Ethernet adapters in here, that has to be connected to, say, a 55 or 5380 processor that has a gigabit port. Whereas, on the 100 meg scale, we still have the Point Safety IO here. And you can see some of the things we have. Typically, we have an input-output module for each of these. Some of these we have bipolar relays. There is one exception where we have an analog input or pulse input in the Point IO. So different things there. All right, that about does it for me. I appreciate your attention. I'm going to turn it over to Gary Smith now for the rest of the presentation.
Thank you, Donnie, and good afternoon, everyone. We're going to now talk about SIP safety output devices. Specifically, we're going to talk about 4 products, 2 Powerfix variable frequency drives, and 2 Kinetics motion products. The Powerfix 527 drive is a compact VFD available up to 30 horsepower. It's also unique in that it only pairs with a Logix controller. It cannot function as a standalone drive. And it utilizes our integrated motion control instructions very much like our Kinetics products. The 527 includes hardware and network safe torque off in the same model.
Hi, Gary. I think we might have lost you. It looks like you're muted.
How's that?
That's much better.
All right, sorry about that.
No problem.
So I was stating that the 755 and 755T are by far our most flexible product line, either in the drive or motion platform. We are able to run permanent magnet or induction motors. The 755 can operate in a standalone mode, or it can reside on multiple different communication networks, and it can also operate very similarly to our Kinetics motion products as well. It's available from fractional up to 6,000 horsepower in a low voltage platform. From the safety perspective, though, the 755 supports multiple different safety cards, and these cards allow you to achieve different safety functions. So you can achieve hardwired or network safe torque off, all the way up to and including advanced safety features that Donnie had hinted at earlier. And these include safe stops, safe limited speed, safe position, etc. And you can achieve up to performance level E depending on the required function. The Kinetics 5500 is a Kinetics servo product. It can operate as a standalone drive or a multi-axis drive. And in multi-axis mode, we utilize a shared common AC and or DC bus configuration. The 5500 is available up to 15 kilowatts and can operate our newer single cable VPL motor design. There are two separate versions of the Kinetics 5500. One version is dedicated to hardwired safe torque off. The other version supports network safe torque off up to performance level E. The Kinetics 5700 is our high-powered servo offering, available up to 112 kilowatts. It can support permanent magnet motors or induction motors. But the key to this product line is it's optimized for multi-axis control. So you will see that there are single axis amplifiers as well as dual axis amplifiers, and they can all be connected together via a common DC bus configuration. The 5700 is also available in two distinct models. One supports either network or hardwired safe torque off only. The other version supports the advanced safety features. So again, like the 755, we can do safe limited speed, safe position, safe direction. And what allows us to do that are the new safety instructions that are available in the L8-based guard logics processors that Donnie had mentioned. So we can do some of these advanced safety features, and I'm going to cover a few of them here. First off is safe torque off, and this is one of the more important instructions. And the reason is this is what is going to completely disable the servo drive output. This prevents the transistors from firing and prevents the motor from developing torque. So the motor essentially will freewheel and cannot develop torque. You will note that I'll reference several times for the safe state in your servo system. This is essentially what we're talking about in the safe state, where we cannot generate torque on the motor. A safe state 1 is essentially a controlled stop or a category 1 stop, where we're going to not allow the motor to coast. Instead, we're going to command it to a 0 speed. Once we achieve 0 speed, we will then transition to a safe torque off mode with no additional control over that motor. We also monitor the deceleration ramp to make sure that we are decelerating appropriately. Safe brake control is a direct control of an external auxiliary safety rated brake. We also synchronize the safe torque off functionality of the drive with the brake control. Safe stop 2 functions similarly to Safe Stop 1, where it is a controlled stop. However, when we get to 0 speed, we are not going to initiate a safe torque off. Instead, we're going to automatically transition to a safe operating stop mode. So at this point, we're going to monitor for either position or speed while the motor is stopped and making sure there is no deviation. Monitoring functions are very important, and the thing to note here is that they are exclusively monitors. Monitor functions reside in your safety task, and they have no responsibility for actually commanding your drives and motors to the desired condition. So in our first example, we have a safety limited speed or safe limited speed function. So there will be a maximum speed assigned to safe limited speed. And once the drive is within that window and we are monitoring at that point, if we ever exceed that maximum velocity, the drive will be forced to the safe state. As previously mentioned, that's safe torque off. We can also do safe direction, where we have an intended direction of the motor. If we ever detect motion in the opposite direction, we will immediately force the drive into the safe state. Safe limited position is going to set up a tolerable window of positions for the axis. If we ever move beyond that allowable window, again, we are going to command the safe state. So how do we do this? I briefly mentioned that the safety task programming, and there's a standard task inside the drive. Well, the safety task is where we're doing the monitoring. The standard task is where we're actually doing the commands to the drive. And this is where you normally have your move instructions, jog instructions, etc. So in this example, we are going to have a demand for a safety function for safe limited speed. And we're going to get an output from that instruction. The transfer of this data happens within our advanced safety drives utilizing what's called pass-through data. So we get an output from our safety task called SLS active. Inside the drive, we're going to pass that through and create a new tag called SLS active status bit. And in the lower right, you might be able to see that that bit is what's going to initiate an instruction called MCD, or motion change dynamics. This is where we're actually going to command that lower velocity, a velocity less than the threshold of the safe limited speed monitoring function. The SLS instruction has a check delay time to give the system time to achieve the desired velocity. But once that timer expires, we will begin monitoring, and if we ever exceed that maximum speed, we will transition to the safe state. So SIP safety examples, there are quite a few different ways you can configure these safety systems, and also depending on how they're configured, you can achieve higher or lower levels of safety. In this first example, we're just simply showing a Kinetics 5700 drive with a GuardLogix processor. And within that GuardLogix processor, we're supporting two different tasks, the safety task and the standard task. This is a very common way of achieving advanced safety on these drives. However, you do not have to architect it this way. If you choose to, you can have a standard GuardLogix processor that handles all the motion control, the standard task motions. You can have a completely separate GuardLogix processor running a safety task that handles the safety. And how we accomplish this is within each of those processors in the I/O configuration, you are going to include that Kinetics 5700 drive. However, for the standard processor, you're going to set that axis up as motion only. And the GuardLogix processor, you will set that axis up as safety only, and we're able to handle both functions. Here's another example of how you might be able to utilize our wide array of products to achieve maybe a lesser cost system that still achieves a high level of safety. For example, a safe limited speed monitoring solution. In this case, we show a Powerfix 527 drive that resides on network safe torque off. However, that drive does not support safe limited speed, safe direction, etc. However, we can add an 843 ES safety encoder to provide those types of functions. And in that case, we're able to achieve the same level of safety, but again, possibly at a lower price point. So here is an example or a scenario where we want to do speed monitoring in our GuardLogix processor. And let's say that based on your risk assessment, you know you only require performance level D. Well, your hardware configuration may look like this, where we have a compact GuardLogix SIL2 version or a GuardLogix L8 standalone processor. We would utilize that 5700 with the ERS4 version and one of two motor options on the output, either a SIL2 rated encoder that's part of our VP series motors, or our older generation MP motors that support sine and cosine feedback. However, let's say that you required PLE capabilities in that same system. The first thing you would have to do is upgrade the processor. So you're going to transition to the SIL3 compact GuardLogix, or you can add the safety partner to your L8 processor. Same drive, and now you would have the same VP motor with SIL2 encoder, but you would have to add a secondary encoder. In this example, a sine cosine. What if we wanted to do this with a Powerfix 755 drive? Well, we would utilize the S4 safety card. For PLD, you would start out with one of those same two processors, either the SIL2 compact or the standalone L8. You'd also have to have a motor with either quadrature encoder or sine cosine feedback with the appropriate feedback card. For PLE, you're going to require the same same processor upgrade to the SIL3 version or the safety partner, and you're also going to have to utilize that second feedback device. So either two quadrature encoders or a sine cosine and quadrature encoder. And in these scenarios that we're talking here, we are usually referring to safety rated encoders. So to aid in the development of some of these safety applications, especially with the advanced safety functionality, Rockwell has come out with a few safety application techniques, and there are more on the way. One that exists today is based on safe limited speed, and it uses either the Kinetics 5700 or the 755 with the S4 card. And as I mentioned, that's available today. If you're interested in seeing a video demonstration of this hardware, if you visit the McNaughton-McKay YouTube channel and you search for Powerfix S4 or Kinetics ERS4, you'll find a link to that video. It's also a very similar overview of safety, kind of what we have done today, but it finishes up with a very good demonstration of how you would utilize one of these networks. There is an existing safe brake control document today that is centered on the 755, but there's a new one coming out later this month that focuses on the 5700. There will be a safe limited speed document coming out that's based on the 843 ES safety encoder that we've referenced several times. And there will even be a safe limited position document, all available later this year. In addition to those application technique documents, there is a lot of information available online to discuss these functions, both the functions and the individual products that we have reviewed. You can always go to ab.rockwellautomation.com, go to the products tab, and from any of the products that you have an interest in, there's usually a documentation tab where a lot more information is also available to you. But if you do have any questions whatsoever on any of that documentation or anything else that we have covered today, please feel free to email us at macandmaclive@mc-mc.com. Just please reference the Safety over Ethernet presentation to make sure that we put you in touch with the required resources. And at this point, I'm going to pass it back to Rachel, and we can see if there are any other open topics in the chat window. And I wanted to thank everybody again for their time today.
Thank you, Gary. We do not have any live questions at this time, but we'll give it just a moment and see if anyone has some follow-up questions for us. Like Gary mentioned, you are welcome to reach out to us at any point after this live session has ended at mclive@mc-mc.com. Just reference the session that you viewed, and then we will forward those questions along to the presenter so they can contact you directly. I want to thank Donnie and Gary for their presentation today. We hope that you found this engaging and useful and very helpful for you. I want to thank Kevin for being our resource in the comments section. And thank you especially to all of our live viewers for your time today. Remember to subscribe to the McNaughton-McKay YouTube channel for more industry content. And we will look forward to seeing you live again soon at our next virtual Lunch and Learn. All right, thank you everyone and have a wonderful day.